is to demonstrate scalable microservices architecture to build the enterprise resilient scalable systems using Azure, C#, and REST APIs for modern cloud-native applications. How we can achieve that? What was the journey for me from moving to monolithic application to microservices? I'll try to give a brief idea on all of these. So starting with the microservices architecture. So what are microservices? So microservices are they are small modules. We can say that these are independent modules and services which we decouple to make sure that all the modules are functioning independently. So if we take an example of e-commerce application, we want all the areas to be work independently. As an example, if I say that my customer is putting the orders and his payments are getting processed, and the vendor is putting a vendor to that e-commerce web application, they're trying to submit their costumes or something like that. So all the functions should go independently. They should not have interdependency on each other. All the things should be loosely coupled. So here the microservices fundamentals comes into picture. So it's like a design approach, independent services responsible for a single business capability. So for microservices fundamentals, I can say each service has their single responsibility. If I take an example of invoicing and payments and application management, employees are getting enrolled, their invoices and payments are getting independently managed. So everything is getting every module is having single responsibility. So we make sure that we make services in such a manner that if one service is getting down, whole application is not getting down, and we are able to deploy them independently. So they have polyglot persistence. That means we are able to design databases for them in such a manner that each microservices is tied to one database. If one of my database is having some issues due to load balancing or something, the other parts of the applications are functioning properly. So this enables fault isolation and scalability of an application. So what is fault isolation? Fault isolation is like my payments are down due to my payment gateway, whichever I'm using is not responding, or one or the other reason. Because of payment gateway being down, I should not stop my customers to put their orders. Although they won't be able to complete they won't be able to complete with their order right now till the time payment gateway is up, but they should be able to enroll themselves, put their items to the wish list, so they can go ahead and complete their orders later on. Now coming to how we are gonna deploy these microservices, what all we can use. We have different platforms which we can use to do the deployment of these applications. We have been using Azure for quite a while. So what are the benefits of using Azure? So they provide container orchestration with Azure Kubernetes services. Those are serverless functions, and they have managed databases. What does container orchestration means? So container orchestration means like I am trying to put all my microservices into containers. I will put them into a container and ship them. That means I don't have any dependency on any of the language. One of my microservices can be in .NET C#, the other can be in Java, or they can be in C++. We can orchestrate them together, ship them, so that they are good to be deployed on the servers. They have they are not dependent on each other. For deployments, what we have been using is the DevOps for continuous integration and continuous deployment pipelines. Nowadays, developers are not tied to like the legacy, like they used to be in the legacy applications that they have to publish the code and copy paste the DLLs. They will just push their code to the GitHub repo, and after that the code is good to be deployed automatically till the time QA till the time any person from the QA takes a look. What language we can, what language we can use? There are multiple languages we can use to implement these. I have been using C# a lot because of the the architecture it provides. So I have been using ASP.NET Core Framework and dependency injection. So dependency injection is like we are not dependent upon creating an object every time. We can directly inject the classes and take advantage of that using Entity Framework and Dapper. What all principles have been we have been using to create this microservices is the REST API design principles. So what are the advantages of using REST API design principles? Is stateless communication. So every call, whatever we make to the backend is stateless. That means every call contains a token. We are not dependent upon the first call to give us the token, and so that we are authorized. Every call, you are making is stateless, resource-oriented endpoints. So if you are making call to the order service, it will be stateless. It is independent of any registration or any employee service. It will be going independently, get you the resources and come back. And Hatios. What is Hatios? Hatios is like hypermedia as the engine of application state. It's a key concept where the customer, where the client would know what to do next. There are many versioning strategies, so that and OpenAI documentation. These are the rich principles, what I can say, available in the microservices. So versioning strategies is like you can make multiple versions of a single microservice or a single action so that you can use it in the different formats. So if you have so take an example of Google Maps. One consumer wants to use the API for Google Maps in such a manner that they have their customized requirement that they want to use in this manner. But the other customer, they want to use Google Maps in another fashion. So you can create two versions of the same API and expose it to the consumers. Moving on to how the journey was from moving monolithic applications to microservices. So over a period of time, I got a chance to migrate my applications from monolithic like MVC architecture to the microservices applications. How the journey looked like, what all decisions we tried to make as a team, and what all things we worked upon, I'll try to explain here. What are the monolithic applications? Monolithic applications are like single code base, tight. They have a tight coupling, MVC based architecture, difficult to scale, and long deployment cycles. As I previously explained that if you make change in payment, the whole application you have to make down, deploy it again, and then make it up. That was the tight coupling, I would say, with all the monolithic applications. What were the benefits of that? For smaller applications, we can still use monolithic architecture. Those are actually we are good with the deployment of those small applications. But with the larger enterprise applications working in healthcare and insurance, what I have observed is if we try to make one portion down, the whole application is getting impacted. So to avoid that, we came up with a microservices journey. We tried to identify how we can break our application into different modules so that they are independent of each other. We cannot directly break the application into different modules. It was difficult to identify that how to make those decisions. We try to make them domain driven. Domain driven is like one domain is having one module. So payment is having one module, invoicing is having one module, registration is having one module, and all the other activities are segregated into different modules. so that we have different boundaries set for improved maintainability. We can maintain them, we can improve them as on the need basis. Try to create independent services, loosely coupled. Loosely working on the software architecture, we always try to loosely couple the services so that they are working separately. Independent scaling and technology flexibility. So independent scaling is like, one of my services might require that I want to horizontally, or I want to scale my CPUs for that. Might be there is a high load on the registrations on a day. There could be chances that we have high load on payments on another day, so that they are able to scale them. We are able to scale them independently as on need basis. What is the gateway requirement for them? So we try to go ahead with the API gateway. So there is a single endpoint, and once the server receives the request, it will automatically distribute the request based upon the request received. You send the request from the client side, API gateway receives the request. Depending upon the requirement, it will break the request, transcribe the request to the different modules. It's like a centralized routing. You're sending to a point, but based upon the requirement, it's getting routed to the specified respective modules. Full microservices ecosystem, scalable distributed services which communicate via application API gateway. There's a benefit. What are the benefits? High availability and organizational alignment. Most of the services are available all the time, till the time you are making sure that you are not upgrading them or you are deploying them. So all the applications, they can be independently deployed, independently managed, and independently scaled. What are the core design principles for any microservices applications? So fundamental architecture principles, they are loosely coupled, independently deployable, and they are well-defined APIs and promote business capability alignment, so that everyone is able to understand with the name that what could be happening in this particular module, and they can work according to that. Single responsibility. If I take an example, if my service is having a lot, and if a new person is joining my project or my company, it will be a lot for him to understand that what is happening, and it will be he'll be juggling into too many responsibilities. Once we divide our application into different modules, we give them single responsibility, they focus on one business capability and own its own data. So any person who is joining or trying to work onto that module, it's a lot easier for a person to understand that what is happening between this particular module, and he can go ahead and complete the tasks according to that module, and can deploy accordingly. Decentralized governance. So now once we divide the application into different domains, it's a lot easier for team or a company or an enterprise application to choose appropriate technologies. So for one module, we might be very good that we will go ahead with the REST APIs and the C# and .NET. For the other module, it could be a lot easier that we might go with the Java or other technologies. So people, we can decentralize governance according to the expertise available and the technology which best suits that particular module. Fault isolations. What is fault isolation and how they are handled? So one particular module might not work due to failure into that, or we might be deploying and could result in an error. But due to that particular fault, we are not totally blocked. We are still able to function in the another modules. So we can apply circuit breaker patterns and gracefully degrade our strategies. We can bring another corresponding service for that particular failure, or we can upgrade the versions or do the another deployments to make that particular fault is handled properly by us. there are another techniques which we can make sure that our APIs or our services are handled properly. We can maintain health checks. We can make sure that they are stateless. We can make sure that there is a multi-instance deployment. So we can make sure that those are deploying multiple instances, so that if one instance of that particular service is being deployed, the other we can make up, and once the main module which we were trying to deploy is up, we can make the main module up. Now the Azure platform for microservices. So when coming to the development, we have chosen the languages, and we have strategized that we will be using this technology. When it comes to the deployment is very important part coming to the software cycle, which has many components associated with it. We have compute, storage, networking, and another AI services related to it. What all we can use to strategize our deployment strategies, so that the customer who is using the application is seamlessly functioning, and he's not facing that issue that this is getting down and face another challenges. We can use Azure Kubernetes services, Azure Service Fabric, Azure Functions. Let's try to see how these are functioning. So as I previously described, Azure Kubernetes services is like you are containerizing your applications and pushing them to the servers. The containers could have multiple technologies, multiple containers of different technologies associated with those particular modules. What is the advantages of this one? Simplifies deployment, managing the applications and operations. So automatic scaling and self-healing capabilities. What is automatic scaling? So if any particular module requires high scaling, high CPU needs, it will automatically scale the CPU according to its needs. Like if you require more CPUs for that particular module, it will automatically scale it in vertical or horizontal manner. So integrated with Azure security and monitoring. Coming to an application, security and monitoring is also the key role it plays into our application. I'll explain you what is Azure security in the coming slides, and how do we do monitoring as well. Azure Service Fabric, distributed system platform for microservices. So it has comprehensive application lifecycle management, supports stateful and stateless services, built-in high availability and fault tolerance. What are Azure functions? Azure functions is a very good feature. So if you are having any scheduled jobs, so but those are running monthly or weekly or twice a week, you can pay according to your usage. So pay per use pricing model. Earlier models, we used to pay for the schedulers like all the time. Even we run them weekly or twice a month. Supports all the programming languages, seamless integration with other Azure services. There is no interdependency that we cannot use Azure functions with another technologies or with another Azure services like Azure Service Bus or any other Azure apps or Azure container apps. We can seamlessly integrate our Azure functions with any of these technologies and other applications. Azure services for microservices architecture. What this have brought for us, what Azure services has brought for us in the microservices architecture. So it has provided us a very good SLA, has been used widely. Auto scaling is the best feature which Azure has been providing. Enterprise security is another key feature which Azure has been providing without any issues. Azure Kubernetes services. These are very good for automated deployments, scaling, microservices with DevOps capabilities. All these capabilities are independently provided by Azure, and we are able to use them without any issues. Automatic cluster management and node upgrades. So cluster management, so if we have independent clusters, those can communicate independently within Azure, and we can provide them upgrades according to the requirement or according to the load which we have on day-to-day basis onto that particular application. What we can use to monitor the application: Azure Insights, Azure Monitor, and Log Analytics. So that if we want to see that which module or which particular area is having the higher usage, we can provide the resources accordingly, or we can handle the things accordingly. Built-in security scanning and policy enforcement. Azure services already they provide us the identity to handle the security for authorization authentication and for all the RBAC like role-based access control things, which we can use to authenticate or authorize our applications. Azure Service Fabric, reliable services with built-in state management, automatic service discovery and load balancing capabilities. We don't have to manually go and increase the CPUs or increase the RAM for any resources required. It is automatic. We can directly use the capabilities which are provided by Azure. Health monitoring. We can check the health status of any services which we write. And if there are any failures, it will try to automatically recover from them. Azure functions, as I have tried to explain, that there are multiple triggers, timers, and queues, so that we can use our schedulers for nightly or batch jobs accordingly and can pay for them according to our usage. Support for multiple programming languages, including C#. They provide a wide variety of integration with different technologies, and there is no interdependency or platform dependency that we are tied to one particular language. We can go ahead and use them for different languages and tie them together. What is why we have been using C#? Because lately Microsoft has released the ASP.NET Core version, which is very lightweight, high performance, and it is very good. I mean, it's very easy to build highly stable HTTP services for REST APIs, which we can integrate with the microservices architecture. The key benefits are like cross-platform support, DI, dependency injection, and modular HTTP pipeline. What we have been using to connect with the database: Entity Framework Core, or we can use wrapper as well, whatever the project needs are. Modern Object Database Mapper for .NET that supports link queue, change tracking, update schema. With Entity Framework Core, the change tracking had been a lot easier. Change tracking is like if you are updating the columns, deleting the columns, adding the data, we can try to track it and provide the details later on. Dependency injection and middleware. Middleware is the key concept of .NET Core applications, where some of the middlewares are already provided by Microsoft. We can directly inject them and use them. We have a feasibility to customly create the middlewares as well, where you create a middleware for some specific context like authentication or authorization, which is being customized for your enterprise applications, and you can inject that particular middleware into different applications. Azure SDK and libraries. So with .NET Core into picture, Azure, the libraries which are provided by Azure, we can easily use them like blob storage, service bus, Azure Service Bus, and Cosmos DB. What are the key benefits? Native integration patterns, resilience features, and cloud optimized performance. It has been a lot easier with .NET Core into picture to integrate with Azure services which are provided by Microsoft. What are the best principles which we can use to design the REST APIs? REST APIs are like the services which we design to achieve our functionality. So it provides a standard approach for microservices communication using HTTP methods, hypertransfer text protocol methods, using status codes and resource-based URLs. It provides a stateless communication as well. Proper API design ensures loose coupling, versioning support, and consistent error handling across distributed services. So, well, if we design REST APIs in a manner that we can avoid to have coupling, we can avoid to have coupling by 40% and improve system maintainability and significantly in microservices architecture. Status codes, we respond from the server via status codes so that we can get to know that my services are working perfectly and if there are any issues or any authorization errors or any authentication errors or any other errors which my service is facing, and I can try to handle them according to the need. What is API gateway pattern and how it is useful? So when a client sends request to the server, an API, we try to provide a API gateway. So client is sending requests in a single HTTP manner, and we try to route them to the respective modules. It provides a way to centrally authenticate and authorize our applications. We have different ways to do that. We can use OAuth or JWT tokens. We have other strategies as well to do the authentication and authorization. You can make middleware as well. You can customly design your middleware so that it is working according to the needs of the application. You can request your routing and load balancing according to the need of the application so that it is properly distributed across microservices. You can try to rate limit and throttle the number of requests, and if there is any abuse or any DDoS attacks which are coming to your application, you can try to log them, monitor them, and cache them according to the need of the application. So if a data is being used again and again, you can try to cache it and try to load it as early as possible. How to manage the services, microservices in different manners. We can design each database for each service. We can try to go with the polyglot persistence, Saga pattern, event sourcing, CQRS implementation, and eventual consistency. What is database per service? So every module can have their own database. The benefits of it is isolation, scalability, and technology flexibility. Polyglot persistence is select optimal database technology per use case. So if we want to combine two modules together and we feel that there could be one database for both of them, we can go according to that. It could result in specialized performance and functionality. Saga pattern manages distributed transactions. So if you try to perform transactions for one particular area, then you can try to implement the Saga pattern for that particular microservice architecture, and we can avoid to have the logs within the database usage. Event sourcing, how to manage our audit trail and enables replay. Full history tracking and temporal queries. CQRS is command and query relationship. So every read and write operation, they are being handled separately, and we can implement our microservice architecture according to the CQRS architecture. What are the benefits of that? Optimized read and write performance and scalability. Eventual consistency, distributed data synchronization approach. Benefits are high availability and partition tolerance. Monitoring and observability. When it comes to the application monitoring, it plays an important role. We want to see that what our APIs are working very good, and what we can do to manage the other what we can do for the other services so that they perform better. So for that, we have Azure Insights. They give us the telemetry that what is the performance of this particular API, or how you can what areas you have improvement for. Includes request rates. What is the request rate coming? If we have a particular area where we have more request rates, what is the response time and dependency tracking with the color-coded healthcare indicators? All these areas, they display that what I can make what I can improve to fine-tune my APIs. Distributed tracing, end-to-end request workflow with visualization across microservices, with correlation IDs and heat maps. And what are the bottlenecks into that? So if I have throttling, if I need to rate, if I need to limit my APIs to a particular rate limiting, then I can also use that. Health checks and circuit breakers, how I can make sure that my APIs are healthy. We can have health status on each API, and we can also we can also use retry and circuit pattern, where we can see that if my API is getting down, how I can automatically check them with red alert, and how can I have a remedy for it, so that if my service is getting down, the option for it is already available, and I can make the other service up corresponding to that, and make sure that user is not impacted. Centralized logging for Azure monitoring across all the application with green blue deployments. Scalability and performance metrics. How I can make sure that my response time is very less and throughput is high. Using microservices, what we have observed is that the response time has been very less for an application to respond, and throughput has been increased using the containerized services. So using containerized services, we were able to achieve almost 5 times higher request handling capability, because the request has been going to different modules all at the same time. We were able to achieve high response time and with lesser response time and higher throughput. And it has the capability to auto scale as well with the horizontal and vertical manner. So vertical is like you are trying to increase the number of the CPUs, and horizontal is like you are increasing the CPU capacity to handle the requests within itself. So it all happens in a automatically. Security best practices for the microservices. How we can, the main part is authentication and authorization. We have Azure Active Directory integration. We have Azure Identity as well for centralized authentication. We can always implement role-based access control with least inputs. We can always enforce multi-factor authentication as well. How we can handle network security between different modules. We can configure network security groups so that they are networking correctly to allow only necessary traffic. We can always implement Azure firewalls as well for traffic inspection. What are the other API security measures we can take? OAuth and JWT tokens. We can also rate limit our requests that, so that we are sending the number of requests which are whatever is required. Data protection can be done using Azure blob containers, Azure storage services, and all transit communications. Also, we can try to implement Azure Key Vault for secure key management. All the third-party APIs like Google or payment gateways, we try to use them through Azure Key Vault so that we can store the key there instead of putting them into our config files, which used to have a lot of data breach, and use them appropriately. Compliance monitoring using the Azure Insights, and check the audit logs and store them according to the need of the application. What strategies have been used to deploy the applications from the time it is checked into the repo till the time it is available to the user? We can use CI/CD implementation, continuous integration, and continuous deployment, which we can achieve using Azure DevOps. So there have been multiple strategies. We can make pipelines for each module and use them appropriately. Pipelines can be secured by putting the variables into that and maintaining the logs for that. And we can also test the pipelines as well using TDD approach. We can whenever we are checking in the code, we also make sure that we have integration with SonarQube as well, so that if we have any vulnerabilities or Veracode issues, we are handling at that point only. We are not pushing them to the user, and we are making images of every module and sending them to the user. For deployments, we are using orchestrations, blue-green deployments, ARM templates and Terraform configurations, automated rollback mechanisms, and canary release for safe deployments. If any issues are there, we can automatically roll back them and release them according to the need of the user for user experience. Yeah, that was it. Please let me know if anyone is having any questions. I have added my details for
Ms. Yukti Goyal.
Thank you. Thank you for giving me this opportunity.
If anyone has any question, they can raise their hand.